Greetings, mathematicians. Let's take a look into our math notebooks and get this started. Today's lesson is 825, add and subtract like mixed numbers. If you haven't wondered why, I've put like in quotations. That's something to think about as we get our notes set up. And on our page numbers, we are in 6L and 6R, and I want to do something with my ruler. Once I've got this in, I want to go ahead and put a red line or a discernible or noticeable break, because up until this point, this was all the information from Quick Quiz 1. Afterward will be Quick Quiz 2. When we've gotten through that information, we'll put another break in our lines. So if we need to go back and study and retake a quiz, we know how to find it in our notebooks. All right, I'm going to flip over to the next page. I've already got a frame set up because this is a long set of notes. So I am on 6L and 6R. I'm going to go ahead and put in my page numbers, 6L, 6R, and we're actually going to go to the next two pages, which will also be 6L and 6R. Let's zoom in on this title for a moment. Get your date, get your title, Unit 1, Lesson 6, add and subtract like mixed numbers. And if you thought like meant that the denominators were the same, you are correct. We're going to be looking at pretty easy mixed fractions or mixed numbers today. And let's go to our lesson focus, our objective, our target. I will add and subtract. Mixed numbers with like denominators using multiple methods. All right, read it one more time with me. I will add and subtract mixed numbers with like denominators using multiple methods. And I think I need to put a comma in there. Using multiple methods. All right, let's get that objective. And two words we need to talk about. Today, our vocab terms, we're going to be looking at ungrouping. So that is where we break a number apart. For instance, if we have, let's see, example 8 1/4, we can actually break it apart. We could say that since we're using fractions of a quarter, we could say it's 4/4 plus 4/4 plus 4/4 plus 4/4. 1, 2, 3, 4. We're almost there. 4/4, 4/4. 1, 2, 3, 4, 5, 6. Almost. Two more. Plus that last 1/4. We could rewrite 8 1/4 as this. That would be one way to break it apart. We could also take the first 1, 2, 3, 4, 5, 6, 7 4/4s and just write it as simply, I'm going to move it down here, simply as 7 wholes, and let's see, what do we have left? 4 plus 1 is, well, what has it always been? You've been doing this problem for quite a while. What's 4 plus 1? 5. Keep the numerator, or make the numerator 5, keep the denominator. So we could ungroup 8 1/4 and write it as 7 5/4. This would be really helpful when we're subtracting if we needed to borrow. We could increase the number of parts in the fraction to subtract. Now, another name for this is reorganizing. Sometimes we can reorganize a number. For instance, if we're going to use that same example, if we have 7 5/4, we can reorganize 5/4 to be, I'm going to just bring my 7 down. We can reorganize that 5/4 as 4/4 plus 1/4. I can send that 4/4 to my 7 plus 1. I get 8. And then I can bring down, get that quarter. So think of ungrouping and reorganizing as ways to undo and redo. All right? So ungroup, break a number apart, reorganize, put it back together. All right. And let's get into adding. If you need to pause, pause. Otherwise, let's keep going. Add like mixed numbers. Now, for this example, we've got 1 2/3 plus 1 2/3. Pretty simple. And let me see if I can get my notes ready. So if we're going to do this horizontally, oh, I need an ly in there. Say it with me, ladies and gentlemen, horizontally. And just a reminder, that means left to right. So we're going to go left to right here, horizontally. Let's add it up. What we're going to do is we're going to take our whole numbers, 1 and 1, and add them separately inside parentheses. So we're moving them over. Next thing we're going to do is we're going to add, and let me switch colors. We're going to take our other parts and we're going to move them over. So we're going to have 2/3 plus 2/3. Now we can add these up. 1 plus 1 is, that's right, 2. Oh, let me keep this color coded. 1 plus 1 is 2, plus 2 plus 2 is 4. Keep the denominator, and we could rewrite this as, I'm going to keep this in red. 2 4/3 is the same as, how many thirds go in there to make one whole? It would be 2 plus 3/3 plus, it's kind of sloppy, 1/3. Let's reorganize this, and we can say that 2 4/3 is equal to 2 plus 3/3 is 3 1/3. Now, either one of these gives us the proper amount, but this one is the answer we're looking for. It's the most accurate answer. So notice, we started left to right, we broke apart whole numbers, add. Fractions, add. Almost to the finish line. We've got all the right number of parts. We just need to reorganize it to get 3 1/3. All right, let's do that similarly but vertically. So vertically, that means north to south. We're going starting at the top and we're moving down. So same thinking here. So let's go ahead and add up our parts. 1 plus 1 is 2. 2 plus 2 is 4. Keep the denominator of 3 because they are like denominators. We end up with a very familiar number we've already worked out over here. So we can simply say that it is 3 1/3. All right. That is adding like mixed numbers, horizontal and vertical. Now there is one more route we can go. Convert and divide. And this one is how I learned as a child. So just a reminder, even though I have the same parts here, I'm going to do a sample up here. 1 2/3. I will multiply my denominator by the whole number, and then I will add the numerator. And we will take that in a clockwise fashion to end up with an improper fraction. So do it with me. 3 times 1 is 3 plus 2. So that would look like 3 times 1, parentheses, plus 2. We get equals 5 over 3. We keep the denominator, 5/3. So what I can do is I can bring it down. I can say, I can convert this. 3 times 1, 3 plus 2 is 5. 5, keep the denominator, thirds. I'm converting it, moving it over. Same problem, easy to redo. I'm adding 5/3. And I can, whoops, my arrow is overshot. 5 plus 5, 10. 3 is our denominator. Now we have an improper fraction. It is the correct answer. It is actually the same as the other answers we came up here. We have to think of it this way. Top down. 10 divided by 3. So if you need to, put it in the box. Do it the algorithm way. 10, whoops. What was I thinking? Let's try that again. Let's grab some space. 10 divided by 3. 10 is in the box. 3 is outside. 3 goes into 10. 3 times 3 is 9. Subtract. You get 1 left over. That becomes our new numerator. And we keep that 3. So our answer is 3 1/3. 3 1/3. 3 1/3. So now you have 3 options. And let me get rid of this and connect it up here. 3 1/3. So we can convert and divide. This is the way I learned when I was a kid. But this one will visually help you get there. All right. All right, I know this is a long one. We're at 12 minutes. If you need to, pause it, complete your notes. Otherwise, we're moving on. Remember, we're in the same lesson, so the page number will also be 6L and 6R. 6L, 6R. Subtracting mixed numbers. We are going to do some ungrouping, some borrowing. Now, just like when we added mixed numbers, we're going to split them between the whole number and the fraction. So we're going to zoom in and see what we can do. Now, let's start with the fractional piece first. Can I subtract 4 from 1? Can I take 4 away from 1? No, I can't. I'm going to have to borrow. So where I get that from is my 7. I'm going to have to regroup this as, let's take 1 whole away from 7. So 1 whole away from 7 would get us 6. And that 1 whole, we're going to represent it as a fraction of 5. So it'd be 6 plus 5/5 plus 1/5. Now we can add those up. What's the 5 and the 1 get us? That gets us to 6 6/5. So we are ungrouping, we're borrowing. So I'm going to cross that out, turn that into a 6, and my 1 turns into a 6. So now I can subtract. Can I take 4 from 6? Yes. 6 minus 4 is 2. Keep the denominator, 2/5. Move over to the whole number. 6 minus 2. We get 4 2/5. So this is ungrouping, also known as borrowing. I know you've done it before. Instead of borrowing 10, we're borrowing the number that the denominator tells us, because that's going to set how much 1 whole is. All right. Next up, pretty similar to what we did with adding. Let's do 7 and 1/5. Let's do the same problem so we know where the answer is going to lead. Minus 2 and 4/5 equals. So we're going to do that converting thing where we multiply and add. Multiply and add. 7 or 5 times 7. What do you get? 5 times 7 plus 1. 5 times 7, 35, plus 1, 36. So I end up with 36, keep the denominator, over 5, minus. Next up, 5 times 2, 10, plus 4, I get 14 over 5. So that converts to 14/5. Now I have a bigger numerator than what I'm subtracting. This will work. So now I just need to take away 34 minus 14 if you need to, or 36 minus 14 if you need to. Move it down. Subtract on the scratch on the side. 6 minus 4, 2. 3 minus 1, 2. I end up with 22/5. This is a correct answer. It's not the final correct answer. We need to do something to this. We need to take 22 and divide it by 5. So 22, 5 goes into 22 4 times. You get 20. 2 is a remainder. 2 becomes my new numerator. Keep 5 as the denominator. So it reconverts back to, and I'm out of space over here, so I'm just going to bring it down. Converts to 4 and 2/5. So both are correct. This is our more accurate answer. All right, and I know I'm pushing the limits of your patience, but I have one more amazing sample for subtracting. This one was new to me. I really like it. I think I'm going to be thinking like this. So this one is called add on lesser number to the greater number. This is a silly name for a strategy, but it actually describes what we're doing. So we're going to start with the lower number in the problem. Remember, our example of the problem was 7 and 1/5 minus 2 and 4/5. So we organize them small to large. Now what we want to ask ourselves is, we want to go to the next whole number. What's the next whole number if this were a number line? Right now we have 2 and almost what number? We almost are getting to 3, the whole number 3. So I'm going to write 2, 3. So how far is it from 2 and 4/5 to a complete 3? Now I'll tell you what, it's the difference between the numerator and denominator. So 5 minus 4 is 1, 1/5. If we add 1/5 to 2 and 4/5, we get to 3. All right. So next, we're going to go to another whole number. So we want to get to that 7. So to go from 3 to 7, how many total numbers? We're going to say from 3 to 7, how many spaces on the number line? Or we could flip it. We could say 7 minus 3 is what? 4 holes, right? We're not quite to the 1/5 yet. So now we want to say 2, 7 and 1/5. So from here to here, how much more do we have to add on? From 7 to 7 and 1/5. It's just a fractional piece. So we can say 1/5. All right, now we can add them up. I can't add the whole number, but I can add these two. So it's 1/5 and 1/5 is 2/5. Bring our whole number over. 4 and 2/5. Oh my goodness. That's exactly what we got on the previous page. So this one is about visualizing distance. How far from this number to the next whole number? From this whole number to the whole number on my larger side? And then we kind of just piece it together. This one will get you to the answer quickly and accurately. All right. For all of you guys, I'm going to say we're going to be in Prodigy for 12 questions so I can get some feedback. And let's see, if you have some time later or you want to work extra on this skill, classwork, pages 15 and 16, or homework, page 11. So this is where I need you to go, but if you want to work more on this skill, you can head here. But this is where we're going, and I will see you in our Zoom meeting. All right, guys, have a great morning.